Now that we've done some simplifying of roots, we're going to want to take some radical expressions and simplify them all at once. So here for my first example, I have 4 root 3 times 2 root 6. And what I'm going to do to actually multiply this, now I'm not going to do 4 times 3 because the 4 is outside the radical. And the 2 is outside the radical here, so I don't do 2 times 6, but I do take the numbers on the outside and I can multiply those. So this has to do with the commutative property. So the commutative property says I can change the order. So I'm going to change the order of these. And now I can do 4 times 2 is 8. And then I have 3 times 6, which is 18. Now there's 2 ways to approach this part. So let's take a look at this 6. I could prime factorize that 6 and have 2 times 3. And the 3 prime factorizes to just to 3. So I could think of it as root 3 times 2 times 3. And then when I multiply, I add my exponents. So I have 2 times 3, a 1 plus a 1 is a 2, 3 squared. And I see that the square root of 3 squared from before is simply 3 to the 1, root 2. Or if we don't want to go through all that, we do this, and then we go ahead and we take our 18, and we prime factorize our 18. And we'll see we'll get the same thing, the 3 squared times the 2, and the square root of 3 squared is 3, so 3 root 2. So in any case, this simplifies to this root 18 to 3 root 2. And notice how I did that 3, so it came out, and then I'll have to erase some of these. So then what I have here is 3 times the 8, which gives me 24. So I have 24 root 2 there. All right, so now a further multiplication problem. This situation right here is like if I had x plus 2 times x minus 5. So I do this, x times both of those, and 2 times both of those, and then I would combine my like terms. So that's the same thing. So I'm going to do this 4 root 3 times this. So the numbers on the outside, 4 times 5 is 20, and then 3 times 7 is root 21, and I know that both 3 and 7 are primes, so this doesn't simplify further. I'll do the next one, and I'm going to remember that 6, root 6 is actually 2 times 3, prime factorized. So I'm going to get minus 4, because this is 1 right here, so 4 times negative 1 is negative 4, root, and then 3 times 3 is 3 squared, times 2. Then I'll do the root 2. Now there's a 1 in front of here, so I'll have 5 root 14. 2 and 7 were prime, so those don't simplify. And then minus square root 2 times this. Now again, I'm remembering that root 6 is this quantity, so I have 2 squared times 3. And in case you're confused what I'm doing there, it's like if I had x to the 4th times x to the 8th, I get x to the 12th. And how did I get that? I added my exponents, 4 plus 8. Okay, so the 20 root 21 is fine. And then if I do the square root of 3 here, I get 3, square root of 3 squared, that is. And then I have 5 root 14. And I just simplify this down as far as I can go. So I have 20 root 21 minus 12 root 2 plus 5 root 14, and then minus 2 root 3, and then that's all I can do. Okay, let's take a look at this one. Now I'm adding. I can't add these the way they are, but it's like this situation. What if I had 2x plus 5x? What would I get? 7x. So if I had like 2 root 9, or let's say 2 root 5 plus 3 root 5. It's kind of like this situation. So I get 5 root 5. I add the numbers in front. So these are not the same. But I can simplify them, so I'm going to go ahead and do that. And if I prime factorize the 18, I get 3 squared times 2. And if I prime factorize the 98, I'll get 7 squared times 2. Now the square root of 3 squared is 3, so I'm going to get 6 root 2. And if I square root the 7 squared, I get 7. And the 7 times 5 is 35, so I have 35 root 2. And then when I add those, I will get 41 root 2. Now, how come I can add them? Well, this is like 6x plus 35x, because they're the same radical. So I'd get 41x there, except in this case, the x is the root 2. Now, this is a division, and this is like when we had imaginaries. We can't have radicals in our denominator, so we're going to have to multiply by the conjugate. The conjugate's the same thing, but different in sign. So square root 7 plus square root 2. All over square root 7 plus square root 2. So now I'm going to distribute that out, and I get 5 root 7 plus 5 root 2. And at the bottom, square root 49. So I did this. Now I'm doing this. So square root 14. Next, minus root 14. And then next, minus root 4. So anything that I can simplify, I do. And square root of 49 is 7. Those cancel, minus 2, because square root of 4 is 2. So then I can simplify that further. I'll do it over here. So I have 5 root 7 plus 5 root 2 all over 7 minus 2 is 5. So this 5 applies to all of these. So I can cancel all 3 of these, and I get root 7 plus root 2. Okay, so now we're going to get this a little bit more complicated. Now let's start with the one at the bottom. So again, multiplying. Before I multiply, I'm going to go ahead and prime factorize these. This is a step that you do not have to do, but I find it easier to prime factorize at the beginning than at the end. So I multiply the numbers in front. So 4 times 3 is 12. 2 times 2 is 2 squared. And I have times 3 times 7. And I'm going to go ahead and end up doing the 3 times 7 because those are prime. I can do the square root, so I do it. So I have 12, square root of 2 squared is 2, square root of 21. So I have 24 root 21. That's my answer. All right, right here. Now I have a few things going on here. I have an imaginary, and I have this multiplication going on. So we need to remember, like something like x times x, that's x squared. If I had something like x to the 4th times x, well, that's like x to the 5th. So all of these are on the inside here, so I can multiply them. And these are on the outside, so I multiply them. So I have 20 square root. Now this 10 is 2 times 5, right? So this is like 2 times 5 right here, and here's my 2. So I'm going to get 2 squared because of these times 5. And then I have x times x, that's x squared. And then I have y to the 3rd times y to the 5th, that's y to the 8th. I'm adding my exponents. So I get 20. The square root of 2 squared is 2. And then I have these in here. So I didn't deal with them. I probably should have right away. Square root of x squared is x. That'll need to be an absolute value. I did the 20 times 2 for the 40. And the square root of y to the 8th is y to the 4th. Leaving me with root 5 on the inside. Now, I dropped my I. There should have been an I out here because I have a negative, right? So I do have an I right here. Okay, so let's see what we can do with this situation. Now, this square root applies to top and bottom. So I have this situation. And then I'm going to split that up. And I do this square root. So I get x. That should be an absolute value. Root x. Square root that. So y squared. Root y. Now I can't leave a radical in my denominator. So what am I going to do? Well, this isn't a conjugate case, but I do need a perfect square right here. So I could do this square root if it were y squared. It's going to multiply by root y over root y. And I'm going to get this. I can multiply those in there. And then root y times root y, if I just think about what that'll be square root of y squared, which is y. And then I'll end up multiplying it in here. So absolute value of y cubed. All right, so now I need a fourth root. This fourth root is going to apply to top and bottom. And as I'm writing this, I'm going to go ahead and split up my x to the fifth to x to the fourth x. And right here, that y is not going to split up. This is the fourth root. So the fourth root of x to the fourth is x, but that needs to be an absolute value because I took a even root and got an odd power. And I have fourth root of x on top still. And at bottom, well, I'm not going to be able to do that. So what do I do? In order to take this root, this number here would have to be a multiple of 4. So I want it to be a 4. Right now it's a 1. So if I multiply by fourth root of y to the third, I get, let's see, 1 plus 3 is 4. So I'll just show this work up here. I have absolute value of root x, fourth root. Now I have x and y cubed all over fourth root y to the fourth. And the fourth root of y to the fourth is y. So at the bottom, I'm going to have absolute value of y, absolute value of x, and fourth root xy cubed. All right. And probably one more example. Yeah. Okay. So these. So just to rehash what we started with, in order to add these, I need to make sure that they have the same thing in the radical. So I prime factorize that 49, and I get 7 squared times 2. If I prime factorize that 32, I'll get 2 to the fifth. All right, so I'm going to split that 2 to the fifth up. I'll do that square root. And the square root of 2 to the fourth is 2 squared. So what is this? It's not 16. It's not like so it's very tempting to do 2 times 2 and get 4 squared, but that's wrong. Exponent first. So it's 2 times 4 root 2. I did that exponent first. So I have 7 root 2 plus 8 root 2, and I get 15 root 2. Okay, right here, this is already prime, so that's fine the way it is. I prime factorize that 12. So I get 4 root 3 minus 7 times 2 root 3. So 4 root 3 minus 14 root 3, which is negative 10 root 3. Okay, right here, I split up that x squared, or x cubed to x squared x. Square root of x squared. Now, I'm not going to be able to simplify this further, so it's fine the way it is. But let's say it was 3 root x minus 2 root x. Then what would I get? 3 minus 2 is 1, so I just get root x if it were like that. All right, again, I prime factorize this. So that's 2 squared times 3. This is 3 cubed times 3. Notice I'm splitting it up. Whoops. I want to split this up. This is 3 cubed, but it's 3 squared times 3. And then if I prime factorize this, 5 squared times 3. So I do my square roots, whichever ones that I can. See, I did that square root, that square root, and that square root. So I have 8 root 3 plus 6 root 3 minus 5 root 3. That's a terrible 3 right there. All right, so 6 plus 8 is 14, minus 5 is 9, so I have 9 root 3. So let's go ahead real quick. I know this is a lot, but just to make sure that we're good on this, let's say that's 8. Let's say I had 2 plus root 10. So how do I simplify this? Times 2 minus root 10. Okay, conjugates. So I get 16 minus 8 root 10. And at the bottom, I'm going to get a lot of different stuff. But when I multiply it out, this is what I get. Okay, so at the top, I have my 16 minus 8 root 10. And at the bottom, I have 4. Those cancel. And then square root of 100 is 10. So I have 16 minus 8 root 10 all over negative 6. Those are all divisible by 2. Now I don't divide that 10. And now we're done. And I think the last one, just to emphasize this point, what if I had 4 over cube root 2? To simplify this, I can't have a radical down here, but this exponent is 1. In order to do this cube root, this needs to be a 3. So cube root 2 squared. Cube root 2 squared. So at the top, I'll have 4 cube root 2 squared. And at the bottom, I'll have cube root. I add these exponents, and I get 2 cubed. The cube root of 2 cubed is 2. If I multiply that, 4. Now I can't do the cube root of 4. The cube root of 2 cubed is 2. And I see that those would cancel. So I get 2 cube root 4. All right, I think that takes care of everything for this section. And just to make sure. Oh, nope. I have a couple more examples. Sure, why not do them? I'll do them fast. Distribute. This 14 is 7 times 2. So get 7 squared times 2. All right. So if I do that square root right there, I would get 42 right here plus 8 times 7 root 2. So 42 plus 56 root 2. And I can't combine those because of that radical. And then these are conjugates. I'm just going to start them. I'm not going to actually do them. This is what we would multiply by. Okay, I guess I lied, so I'll actually do it. Because this one's pretty easy. I distributed. And when I simplify down right there, I'm going to get 5 plus 1. So just to say that I did them, all of those are divisible by 2. So root 5 plus 1 all over 3. Right here, I'd multiply by 4 plus root 2. That's the conjugate. So at the top, I'll get 12 plus 3 root 2 plus 4 root 2 plus root 4. At the bottom, when I'm done simplifying it down, I'll end up with 16 minus root 4. Because a lot of things will cancel. So I got at the top 12 plus 7 root 2. Now this is square root of 4. That's going to become 2. So this is actually going to be a 14. And then this is 2. So I get 14. I can divide those all by 7. And this by 7. And we're good. All right, now we're done for sure.